the damage and claim statistics show a rather high damage ratio due to loss of anchors, which has also been increasing in recent years. The average insurance claims are rated as one of the top 5 incidents. Grounding and collisions as a result of dragging or loss of anchors has caused a series of severe pollution incidents. Investigations show that most of these cases can be avoided by proper inspection and maintenance and improved operational procedures, and awareness of the limitations of anchoring systems. In this case, the bulk carrier stayed at anchorage despite weather forecasts predicting force 8 to 10 winds. During the night, winds picked up to 20 to 25 meters per second with a significant wave height of 4.5 meters. The ship started dragging the anchor and attempts to leave the anchorage failed. DNVGL, GARD and the Swedish Club want to bring your attention to some essential aspects of anchoring. Technical issues account for a significant portion of the anchor losses and can roughly be divided into 5 main components. The most critical detail is the D-shackle connecting the anchor to the chain. The D-shackle bolt is locked in place by a tapered pin, which is secured by a lead pellet hammered into a dovetail recess. Without the securing pellet, the pin would fall out and the anchor would be lost. The D-shackle connection should be inspected as frequently as possible. However, safety requires that nobody is below a hanging anchor. There have also been some cases involving failure of the Kenter shackles if not properly assembled. These are used to connect the anchor chains. The swivel pin is crucial for avoiding too much twist of the anchor chain. There have been some cases where the anchor has been lost due to detachment of the swivel pin from the link. Wear and tear weakens the connection between the securing nut and the eyelet pin, so look for excessive slack. An anchor chain is no stronger than its weakest link. The most typical defects in anchor chains are wastage due to wear and tear. The chain studs may also come loose and fall out. These studs have excessive slack, significantly weakening the chain. If studs are lost or dislocated, the class society must be informed, and special precautions are to be taken during anchoring to reduce the load on the chain until the chain is replaced or repaired according to approved procedures to the satisfaction of the classification society. Here is an example of unauthorized weld repair of studs, showing that it is dislocated and welded on both sides. The chain stopper and brakes are to be engaged when at anchor and during voyages. The chain stopper is designed to relieve the anchor winch brakes. Chain stoppers which are not properly engaged have caused loss of anchors and chains. This one is no longer effective. A more typical problem is a bent or even lost hinge pin for the chain stopper. The windlass brake system is essential to secure a controlled drop of the chain. Corrosion and mechanical wear of the brake surface and linings will reduce the brake efficiency. The brake needs to be adjusted and maintained according to the maker's instructions. Many anchors are lost due to the uncontrolled run-out of the chain. Due to the risks to the crew involved in these operations, regular risk assessments should be held with focus on personal safety. Anchoring is considered by many seafarers to be a challenging exercise, as about 50% of anchor losses are related to faulty operations. Planning the anchoring is an important part of good seamanship.
I suppose we can drop the anchor about 1 mile. Yeah, 1.5.
This includes an evaluation of traffic and congestion in the area and finding out if there are pipelines or cables close to the anchorage. The water depth is a crucial factor. The windlass motor is typically designed, in accordance with minimum class requirements, to lift the anchor with 3 lengths of chain in the water, that is 82.5 meters. The anchor holding power depends on the paid-out length of the chain cable relative to the water depth. If the weather conditions are close to the maximum environmental limits, the recommended cable length is at least 6 times the water depth. Weather forecasts should be noted and the weather should be closely monitored during anchoring, and criteria for when the anchoring should be aborted should be clearly defined by the master. Lack of proper attention and awareness to this has proven to be one of the main reasons for loss of anchors. The anchor equipment is typically designed in accordance with minimum class requirements for a combination of 25 meters per second wind and a 2.5 meters per second current, but no waves. An equivalent load may be defined for waves with a significant height of 2 meters, combined with 1.5 meters per second current and 11 meters per second wind. The nature of the seabed has a significant effect on the anchor's holding power. The best holding power is provided by clay, but this can have a sucking effect that needs to be considered for prolonged anchorage. Also, shingle and sand may provide good holding power. Pebbles and cobbles and soft mud have low holding power, and anchors in such grounds may drag slowly, making dragging difficult to identify. Anchoring is not recommended on shell or rocky bottoms, or on slopes where the anchor may become wedged in a large crack or get lodged in large fissures. Pilot books and guides to port entry contain detailed information about the anchorage, seabed characteristics, and prevailing conditions. These should be used along with the largest scale chart or ECDIS. If the engine or essential equipment is demobilized for overhauls or repairs, proper risk assessment is necessary related to reactivation time. Before dropping the anchor team must be called to stations. The master must determine in advance the side on which the anchor will be used. The standard instructions to the anchor team must cover manning, communications, and the orders used for anchor operations.
Prepare the port anchors to drop.
Drop port anchor.
Any deviations from standard procedures need to be communicated up front. The vessel speed must be reduced to nearly zero or very slow motion astern when the anchor is dropped.
Let go. Let go.
There are 3 ways of letting anchors go, and they are suitable for different environmental conditions. Let go of anchor can be used in relatively shallow waters up to 20 to 25 meters with soft seabed. The anchor is let go from the hawser pipe or lowered a few meters from the hawser pipe before being let go. Lowering by the windlass and let go controlled by the brake means that the anchor is lowered by the windlass until 10 to 15 meters from the bottom, and then let go while being controlled by the brakes to limit the dynamic loads from the weight of the anchor and chain. This method is suitable for a depth range of 25 to 50 meters and for hard and rocky seabed when any significant impact may damage the anchor. Lowering by the windlass to bottom is used to anchor at depths of more than 50 meters and when the seabed consists of rock. The anchor chain remains clutched into the gear and is paid out to the bottom. The paid out length of the chain cable relative to the water depth, the scope, recommended by class is 6 to 10. But in calm conditions, less scope may be considered, but normally not less than 3. While the ship is at rest at the anchorage, always monitor the weather forecast. If heavy weather is approaching, leave the anchorage in time. When the chain has been laid out, the brakes and the chain stoppers should be engaged to secure the chain. The gear must be disconnected from the motor. Check the position at regular intervals using electronic and manual means to monitor that the ship stays within the swing circle based on the length of the chain. When the vessel stays at anchor for a long time and the current and wind swing the vessel around the anchor, heave the anchor and re-anchor from time to time, to avoid knotting the chain and fouling the anchor with the ship's own chain. Heaving anchors in strong wind and high seas is extremely challenging and should be avoided by proper monitoring of the weather and by departing before the conditions become tough. Mistakes often result in groundings or collisions. The key is to monitor environmental conditions and leave the anchorage in time before adverse conditions put the operation at risk. This is vitally important, as almost half of the reported anchor losses are due to excessive environmental loads. Good practice is to maneuver the ship towards the anchor to minimize the tension in the chain. Close cooperation between the bridge and the deck team monitoring the strain in the chain is essential, especially if the waves and ship motions pick up. The key is to limit the strain on the chain using good seamanship. It's essential to keep in mind that the anchoring equipment and the windlass motor are not designed for heavy weather. Under no circumstances must a drifting ship be allowed to pull the anchor chain out of the windlass with the hydraulic motor engaged, as this may cause the motor to explode. The anchor should be properly secured in the hawse pipe to prevent it being lost during the voyage. Excessive slack may also cause hammering on the ship hull and the loss of the D-shackle securing pin. Secured anchors have to be put on tight brakes. The chain stoppers are to be engaged, and the chain should be further secured by lashings with turnbuckles or other similar fasteners. The windlass clutch has to be disconnected from the gear at sea to avoid the risk of damage. So to avoid this happening, increased focus and situational awareness are essential factors for any anchoring operation. To summarize, the most important factors are the securing pin of the D-shackle bolt, the environmental limitations of the equipment, including the depth limitations of the anchor winch motor, adjusting brakes according to maker's recommendations, and replacing brake band linings before excessively worn, and the importance of leaving the anchorage in time if heavy weather is approaching. DNV-GL, GARD, and the Swedish Club hope this presentation may contribute to a safer operation while anchoring your ship.